of product of binomial expansion. So if I quickly write it for you, I have a 1 plus kx to the power 4, 1 plus x to the power of n. Okay, that's what I have. So what I have on the right hand side are the result. And if you have the the 3 lines here means equivalence. It is not to solve an equation. This is not true for certain values of x. This is true for all values of x. You know, so the left and right, they are the same thing. They're exactly the same. That's what it means. So 1 plus 13x plus 74x squared, they say, goes up to k to the power 4, x to the power of n plus 4 is what I have. Okay, so that, my friend, is what I have. So my job here is whatever the expansion I do, I'm going to compare with the constant, linear, and quadratic terms, you see? I got to compare that, but I think constant term is pretty trivial because you're going to have one coming out for the constant expansion here, you see? Okay, so what I reckon here is maybe I should expand the first part here using the sigma definition. So sigma r is equal to 0 to 4, or choose r, k to the power of r, x to the power of r, times, for the second one, that would be j is equal to 0 to n, and choose a times x to the power of j. Okay, that is what I have done with the binomial expansion definition of each. But I think the constant is trivial because both of them are 1. So there's nothing I can derive something in terms of k or n. So I would not use it. But if you look at the second part, I have a 13x, you see? So your job here is then to derive the linear term that is coming out of this expansion. But obviously I'm not going to expand this entirely, but only attack on what? To derive the linear term, I know I'm going to attack here with the constant. If this is a constant, then this needs to be paired by what term of the second? Linear, right? Or it can be linear times constant, you see? Other way around. So that is our job. That, my friend, is our job to work with. Okay. So from this, what I'm going to do is let's try to derive the constant term for here first, which is when r is equal to 0, that will be just 1. But on the next one, if j is equal to 1, that will be linear. So n choose 1, I really hope that you guys know that it's going to be just n. So that is the linear term coming from him. Okay, very happy. And now if I want to try the linear term of that, it's going to be who? Is when r is equal to 1, so it's going to be 4 choose 1, k, x times, and the constant term of that is when j is equal to 0, which is simply 1. And 4 choose 1, I really hope that you know that it's going to be simply 4, right? And since we are doing OR, we're going to add them together. So I know from the left-hand side, I'm going to have the linear term of n plus 4k times x. And that is same as a 13x, you see? That was from the right-hand side. This is the left-hand side. Since their expansions are the same, the linear terms coefficient must be the same. So now I've got an equation of 13 in terms of n and k. So that is what I have. I'm very happy. But then obviously I can't solve this but for n and k because I don't have enough equations. I gotta derive the second one from the quadratic expansion. So on the right-hand side, I was given 74x squared. I'm given the quadratic term there. So because of that, if you look at this part, what do you expect to have? I want to derive the quadratic. I want to derive the quadratic. That means either you can have quadratic times a constant, or the constant times quadratic, or you want to derive who? Linear times linear, right? So that is going to be the, what is it? Expansion of a quadratic term. That is going to be the expansion of a quadratic term. So So let's have a look at the quadratic term coming from here. That's when r is equal to 2, right? 4 choose 2 is same as 6, right? I really hope that you guys are able to compute that quick by now. So 6 times k squared x squared. And then the constant term, we already discussed that from him. That's when j is equal to 0 and choose 0 is 1. So just 1. Or the constant term times the quadratic term of that is going to be and choose 2x squared. Okay. But for the linear, that's when r is equal to 1, j is equal to 1. You see? So it's going to be, what is it? 4 choose 1, k, x times, and choose 1, x. So if we add them all together, what I have here is, what is it? 6k squared plus, for him, it's going to be n choose 2, which is the same as n minus 1 over 2, plus, for him, it's going to be 4 plus n. And if I group them, x squared should be now 74x squared. Okay? So all that sum of the quadratic term, their coefficients, should equal to the coefficient of the right-hand side. So now I've derived the second equation in terms of n and k. I have derived the second equation in terms of n and k. Coming from the coefficient of linear as well as the quadratic term. So now what you have to do really is solve it, right? You should be able to solve this simultaneously simply because why? 2 missing parameters, 2 equations, we're good to go. Okie dokie. So make sure you try this as an exercise. I'm gonna move on to the next one. Oh yes, this one also a lot of people got wrong. So in the question, what they're saying is the following. Now I have a binomial expansion of a plus x to the power of n, where it's a to the power of n plus alpha x to the power of r, beta x to the power of r plus 1, gamma x to the power of r plus 2 plus x to the power of n is what I have. Okay, this is what I have. And so what they're asking me is to get the ratio of who? They asked me to get the ratio of alpha over beta. And then that should be r plus 1 over n minus r, 8. That's what they asked me to get. But as you can see, alpha is a coefficient of x to the power of r, beta is coefficient of x to the power of r plus 1. So what I'm going to do is obviously use this, expand this by the binomial theorem, right? So simply this will be r is equal to 0 to n. So let's not use r because it's one of the parameter there. Maybe just k is fine. N choose k, a to the power of n minus k times x to the power of k is my binomial expansion. And then remember, I need to have the coefficient of who? X to the power of r, x to the power of r plus 1. So when k is, for example, r, then your term would come out as a n choose r, a to the power of n minus r, x to the power of r. Okay, that's the coefficient of the x to the power of r. When k is a r plus 1, then it's going to be n choose r plus 1, a to the power of n minus r plus 1 times x to the power of n plus 1 is what I have. Okay, this is what I have. And we now realize that is alpha and that is beta. Okay? Because they are the coefficient of the terms that we wanted to find. So this is your alpha and this is your beta. Okay, alpha, beta. I have alpha and beta. So far, so good, but we wanted to find the ratio. We wanted to find the ratio of the alpha over beta. Right? I want to find the alpha over beta. So let's try it, Then the alpha is same as him. And this is beta. And as I've said, now I got to simplify. I think this is a lot easier to simplify because the base of 8, because they're together, I'm dividing. When you divide the power by power, you just subtract the powers, right? So all I'm going to do is I'm going to subtract the power here, you see? So if I merely just work on him, that's the same as a to the power of n minus r minus n minus r plus 1, you see? Which then n cancels out. A to the power of negative r plus 1 cancels out. So this ends up being just a. No problem.